Hello everybody, am I audible? Hello? Am I audible? Yes or no? Please let me know in the chat box, please. Hi, hello everyone. Good evening. Am I audible? Yes or no? Yes or no? Yes, thank you so much. So, இன்னைக்கு வந்து we are going to discuss I was planned for 3 chapters ஆனா வந்து கொஞ்சம் what to say, few things has been happened, so I was supposed to limit the lectures to 2, but even though if possible we will also cover the third chapter as well. So இன்னைக்கு வந்து we will be starting with semiconductors. Okay, we will start with semiconductors. அதுக்கப்புறம் we will be going for dual nature, and அதுக்கப்புறம் if we are getting time we will also go for nuclei as well. And in the class வந்து it is not going to be that elaborated. Okay, இது வந்து exam point of view ல what we need to study, what are the things we have to focus, அது மட்டும் தான் we will be discussing in the class. Okay, everybody is ready? So those who have joined right now, don't forget to like, also share with your friends, as well as subscribe the channel. Yena we are giving all the lectures, all the classes, everything for your CBSE board preparation. Adanala you have to subscribe, and also you will be getting you will be getting the updates as well. So again, if you forgot or if you couldn't, this update wouldn't even reach you after the exam, or let's say after whatever be the things supposed to happen, aneki vante if you are getting that, it is not at all useful. Adnala da solra, you have to subscribe the channel. Okay va, ready ah? Ellarume happy ah iruka? Ellarume happy ah iruka? Yes or no? So how is semiconductors for you? Semiconductors vanti easy chapter, difficult chapter for you people? Easier? Tell me. Easy chapter. So இன்னைக்கு வந்து semiconductors we are going to start. So we know that in the semiconductor also, as I mentioned, you can share with your friends now. Okay, we are just started, so ask your friends to join the session. Okay, so on the semiconductors இன்னைக்கு வந்து whatever be the electronic equipments, whatever we are using, அது வந்து it is only or let's say in the semiconductors irundadanaala da whatever we are using, whatever be the electronic equipments, it becomes more compactable as well as it was getting more output as well. Okay, so adanala da இந்த chapter வந்து ரொம்ப important ஆ இருக்கு. So first வந்து energy band. Okay, so let us say இப்போ வந்து we have an isolated atom. Okay, we have, one second guys, just give me a minute. Okay, so இப்போ வந்து we have an isolated atom. Okay, இப்போ வந்து we have an isolated atom. In the isolated atomல we can see that in different orbits we have many electrons. In the each orbitல every electron will have energies, and the energies represent, we will represent the energies. Appo vanda we will be getting the energy levels like this. Okay, little bit specific. Ana vanda we know to get an isolated atom is not easy. Correct ah? இந்த மாதிரி isolated na அந்த atom மட்டும் தான் இருக்கு. ஆனா வந்து we know that always it will be associated with the neighboring atoms. Yes or no? It will be always associated with the neighboring atoms. அப்போ வந்து இந்த energy levelsல okay, அப்போ வந்து இந்த energy levelsல இப்படி இருக்கும். there will be infinite number of energy levels. Energy levels now very simple. It is nothing but the energy levels of energy band வந்து energy levels of each electron. Okay, and we will call it as energy band. Energy band na enna? Energy level da. இந்த electron energy level represent பண்றது. So that is nothing but energy band. Yes, of course Nandakumar, this is enough. Wave optics வந்து we will be doing on Friday. Ray optics with wave optics we will be do it on Friday, don't forget. Okay, you can attend that session. So in the chapter la vandu hardly very few number of numericals da varu, that type of questions I have added in the session. And also as I mentioned, we will cover PYQ separately on I think Tuesday or Wednesday we will cover. Okay, I will give you a proper schedule for you people, don't worry. Yes, of course marathon will be there in the last 2 days. In the Sunday kuda marathon da. Okay, and the marathon la vandu we will be doing only concept revision. Okay va? Okay, okay, so fine. So right now we were discussing about the energy band. Energy band na enna? Energy levels of this electrons. And in the energy band la vandu we have two types of band. One is nothing but valence band, another one is nothing but conduction band. Valence band na enna? Definitely valence electrons irukum. The outermost shell la irukra electrons da. Okay, outermost shell la irukra electrons da valence electrons. And the valence electrons oda energy da. Okay, this is nothing but the energy levels of the valence electrons. Valence electron na enna? The outermost shell la irukra electrons. And the electrons oda energy da valence band la irukum. Next vandu conduction band. So conduction band vandu valence band, I mean if valence band was here, then definitely in the conduction band vandu it will be on the top of valence band. Energy vandu it will be little bit more. Okay, and in the conduction band la irukra electrons vandu free da, it can move anywhere. Ana vandu valence band la irukradha I mean valence band la electrons ku vandu it is immobile, we cannot, I mean it cannot move. Purinjida? Yes or no? Everybody, yes or no? I'm not getting the chat there, I don't know. Okay, so I'm just looking, sometimes I'm looking here. Okay, fine. So this is the three bands we should know. Next one, the energy gap da. Okay, energy gap. So right now we got to know what is the conduction band, what is the valence band. In the conduction band oda valence band oda in between irukra the space da nothing but energy I mean energy gap. So ipo vanda let's say this is the valence band and this is the conduction band, and this distance is known as this distance, or let's say that separation, that energy level separation is known as the energy gap. Okay, ipo vanda we have studied 4 new terms. First one, the energy band. Energy band na enna? Very simple, it is nothing but the energy levels. Okay, next one, the valence band. The valence band na enna? The energy possessed by the valence electrons. And then conduction band. Conduction band na enna? It is nothing but the electrons, the energy of the electrons in the conduction band. Okay, next one, the energy gap. Energy gap na the distance of separation between the bottom of the conduction band, okay, with the conduction band, and to the top of the valence band. That is the energy gap. So in the energy gap the I mean this is how we will be segregating the conductors, semiconductors and insulators. Ipo vanda in the energy gap is more than 3 electron volt. Okay, ipo vanda in the energy gap vanda more than 3 electron volt. Okay, if it is more than 3 electron volt na, we will say that is nothing but an insulator. That is nothing but an insulator. Ipo vanda in the energy gap less than 3 electron volt na, we will say that is nothing but semiconductors, which means the separation between this valence band and conduction band வந்து கொஞ்சம் கம்மியா தான் இருக்கும் இந்த கேஸ்ல semiconductorsல. ஆனா conductorsல வந்து what will happen? Conductorsல வந்து what will happen? Yes, this valence band and conduction band வந்து overlap, it will overlap each other. Okay, so in the energy gap 3 electron volt oda, I mean if it is more than 3 electron volt, we will call it as insulator. Less than 3 electron volt na, we will be call it as semiconductors. Purinjida everybody? Don't forget to like, guys. Okay va? Everything is okay? Please let me know in the chat box, please. Yes or no, you guys understood? Yes or no? Yes or no? Okay, so for the conductors, as I mentioned, the valence band conduction band they will overlap each other. Otherwise otherwise there is another thing is nothing but we can say in the valence band la empty space irukum, and in the conduction band or let's say we can simply say it will be partially empty, conduction band partially filled. Okay, so idu da in the segregation. So this you should know this value 3 electron volt. If it is more than 3 electron volt, energy gap, then we will call it as insulator. Less than 3 electron volt, we will call it as semiconductors. Semiconductors la we will be talk about silicon as well as germanium. In the silicon definitely the energy gap 1.1 electron volt and germanium 0.7 electron volt. Okay, most of the cases in the value they will be giving in the question paper, and we should make sure we know, even if it is not given, we know this. So silicon oda germanium oda in the energy gap value you have to study. Understood everybody? Yes or no? Let me know in the chat box please. Let me know in the chat box. Okay, how to tackle 1 mark, ma'am? Study no, you have to study, nothing else. You don't need to do anything, you just study. Okay, okay, very good Nantakumar. And what's his name? Darsh, Smani, Shobana, Gayatraya, right? If I'm pronouncing it wrong, very sorry. As I mentioned, I'm not a proper Tamilian, I'm from Kerala, so I have some difficulties in the language, so please, I'm saying sorry if I'm pronouncing wrong. Okay, okay, yes Harish, okay, very good. Okay, so now we understood the energy gap and the values as well. As I mentioned, you should know silicon 1.1 electron volt and germanium 0.7 electron volt. Got it? Everybody understood? Don't forget to like, also subscribe the channel. Okay, everyone should do it. Okay, done. Now we are going to focus on the semiconductor part. Okay, now we have two types of semiconductors. Okay, we have two types of semiconductors. First one the intrinsic semiconductor. Second one the, what is the next one? What is the second one? Tell me, what is the second one? Extrinsic semiconductor. Understood? So now we are going to focus on intrinsic because that is romba easy thing. Okay, it is very easy. Intrinsic semiconductor that is the most easiest portion in the semiconductor. Okay, yeah, that's pure. Okay, pure na, it is easy to understand. Okay, correct. Yeah, I think video, audio, everything is perfect, right? Yes or no? Please let me know. Can I let me know in the chat box? Is there any issue with the audio, video? Please let me know, because it got stuck here. Yes, thank you. I got one perfect, that is enough. Okay, so intrinsic semiconductor, because I wanted to finish this chapter as soon as possible. Okay, as I mentioned, I have few things to do. So adanala konjam, I mean, we without much distraction, we are going to finish this chapter. Okay, so intrinsic semiconductor na, as I mentioned, that is pure. Okay, silicon, germanium, nothing is there. They only, it is just silicon, it is just germanium. Now in the 0 Kelvin temperature la what will happen to this? This is insulator. 0 Kelvin la insulator da. Purinjada? So intrinsic semiconductor la whatever we are saying, the silicon or germanium, adu romba pure. Pure na definitely on the 0 Kelvin la adu is a insulator. Okay, and when we are giving temperature, okay, so last class when we were discussing about current electricity, I have told you one thing, in the alpha value in the semiconductor alpha value, do you remember that? Those who attended the last session, alpha value the temperature coefficient negative da, which is representing that when the temperature increases and the resistance decrease agum, conductivity increase agum. correct? So ipo vanda we understood it is a pure state. It is in the pure state, and when we increase the temperature from 0 Kelvin, what will happen? In the resistivity it will reduce, conductivity increases. Okay, conductivity increases. Okay, so what will happen due to this conductivity? Okay, there will be electrons, there will be holes. So you will be feel like, what is this electrons and what is this holes? Okay, electrons now we already know about electrons. Okay, is there any problem with the audio? Is there any audio problem? Okay. Current electricity notes I will definitely share. I think you will receive today itself. And also one more thing, I am doing 10 minutes quick rapid revision for each chapter. So you can just check in the channel, you will be getting the videos. And if you are thinking like, I know this chapter, let's just go through the that rapid revision, which will make you more confident. Okay, so don't forget to watch those videos. Understood? Okay, so we have discussing about intrinsic semiconductor. So now we have increased the temperature. So when we are increasing the temperature, as I said, the conductivity increases. So in the silicon order 4, in the silicon germanium 4 valence electrons da irukku. If I'm just going for the diagram, you can see here, idu da on the crystal order structure. Okay, these are all one, it's nothing but silicon. So what will happen? It is having 4 valence electrons. Whenever we are giving the temperature in the covalent in the covalent bond it is having with each silicon, it will break. When temperature increases, the covalent bond will break. Okay, what will happen? From 0 Kelvin, when we increase temperature, it will break the covalent bond. Okay, it will break the covalent bond. Purinjada everybody? Understood everybody? So temperature increase pannumbodhu, it will break the covalent bond. Appadina, if it is breaks the covalent bond, there will be a free electron. Let's say this got break. Okay, so we have a free electron. Okay, we have a free electron. Now we have a free electron. Okay, free electron na free. Okay, now when this, from this position only it has escaped. Okay, it has escaped. Appadina, inge we will be having a vacant space. Understood? So when this covalent bond breaks, what is exactly happening? The electron become free. Okay, it will create a vacant space, and this vacant space is known as, what? That is what we are calling it as hole. That is representing electron deficiency. Okay, it is representing a electron deficiency. So what we said, when temperature increases, resistance decreases, covalent bond breaks, then the electron becomes free, and because of that there is an electron deficiency, and that electron deficiency is called as hole, and electron ku vanda negative charge. So in the vacant space ku vanda we will say it is positive charge. So whenever we are whenever we are increasing the temperature, adula vanda free electrons and same we can say that there will be holes also generated. Appa vanda I can say one thing. In the intrinsic semiconductor la the number of electrons will be equal to number of holes. Idu romba important, you should know. Intrinsic semiconductor la the concentration of electron and concentration of holes equal. Yena 1 electron escape, which means 1 vacant space. 2 electron escape, which means 2 holes. Okay, so 2 electrons will become free and it will be creating 2 vacant space. Purinjada everybody? Everybody understood? This is very, very important. The concentration of electron and concentration of hole in the intrinsic semiconductor is same. Everybody got it? Everybody got it? Yes or no? Voice is having any problem? So now is sorted? Hello? Can you just let me know now? Hello? Hello? I will do for all the chapters, Shobana, don't worry. We will cover all the chapters. Okay? Okay, I hope it's fine now. Okay, fine. Perfect. Okay, I'm not getting the chat. That is why I'm not, if I need to get the chat, I have to come here. Okay, let me just try one more time. Just give me a second, please. No way. Okay, fine. Okay. Yeah. So let us just go again. So intrinsic semiconductor, I will repeat again what we have discussed. When temperature increases, covalent bond breaks, electron will become free. If electron becomes free now, there will be a hole generated, there will be a vacant space, or let's say there will be an electron deficiency. And electron ku vanda negative charge, adanala vanda hole ku vanda we will say positive charge. And one electron escape, which means one hole. So ipa vanda we can say the concentration of electron and concentration of hole vanda same in the case of intrinsic semiconductor. Okay, and right now we are going to find the current. Okay, we should know how the current is produced, because let us say if I am saying the electron escapes, okay, one electron escapes, and what happened, as I mentioned, there is a vacant space. Okay, now this electron shows that okay, there is a vacant space. Then what it will do? Yes, it will move from here to here. Okay, now I am focusing on the holes part. What will do this hole? The hole will shift to the electron. So now we can say that whenever an electron shifts, the vacant space will be there. Next one, there is a vacant space. Up in the next electron one, it will be replaced over here. Up one the vacant space. Okay, so now I will just show you a very simple thing. Let us say this is the conductor what we have. Okay, just focus on this. This will give you a clear-cut clarity. Okay, so we have these electrons. Okay, these are the electrons we had. Now what happened in the electron one, the escape action. Okay, here we have a hole. Here we have a core. Now what will happen? Listen here, it is very important to understand. This understanding is very important. If the electron escapes and it created a hole, or let's say it has created a vacant space. If in the electron, it will be move here, and in the hole move towards here. Okay, and next what will happen? Right now there is a vacant space. Okay, the vacant space ingida. Okay. Again what will happen? Another electron next to that, the another electron it will replace here, and again the hole will shift towards here. Am I right or wrong? Okay, இப்போ இங்க ஒரு vacant space இருக்கு, இங்க ஒரு vacant space இருக்கு. இந்த எலக்ட்ரானுக்கு புரிஞ்சிடுச்சு, இங்க ஒரு vacant space இருக்கு. It will move towards here. Okay, அப்ப vacant space இப்படி. Okay, so I can say that if electron is moving towards my left side, the holes will be moving my right side. Am I right or wrong? Did you guys get it? Yes or no? Yes or no? Yes or no? Tell me. So all the time when the electrons move towards left, I can say that this vacant space will be moving in the opposite direction. Very good, very good. Now we sorted up everything. We know that the current order direction, if it is due to an electron flow, okay, if it is due to an electron flow, what is going to be the current direction? Current we have studied, current direction the opposite to the electron flow. It will be opposite to the electron flow. Am I right or wrong? Tell me in the chat box, am I right or wrong? Yes or no? It is correct. Even if you say no, it is correct. Okay. Definitely what will happen? The current will be in the opposite direction. I can just say that this is how electrons will shift. Correct? Electrons will shift here. So I can say the current due to the electron flow in the direction. Understood? Yes, yes. Very good, very good, very good. Okay. So right now current due to the electrons we understood. Next we have vacant space. This hole is also moving. and what is going to be the direction? It is towards this direction. So I can say that the current due to hole also in the same direction. Appadina, the net current in the intrinsic semiconductor will be coming as IE plus IH. Everybody understood why we have taken the direction? Okay, if you understood, don't forget to like, subscribe and share with your friends. Okay, so I will repeat again. This one, I mean, this one romba important concept. When electron shift, the holes will be shift towards the opposite direction. Okay, இப்போ வந்து electron வந்து rightல shift பண்ணிட்டு இருக்கா, so holes வந்து leftல it will shift towards left. அப்படினா we know electrons on the right side, அப்ப அதோட current வந்து left side, holes வந்து left side positive charges தான், so அதோட left. அப்படினா the net current வந்து it is going to be the sum of electron and holes, the current due to electrons as well as hole. Everybody understood? Can I get a heart in the chat box if you understood? Can I get a small heart in the chat box, please? Please let me know how many of you understood. Come. I mean, I want some more energy in the chat box, please. Let me get it. Very good, very good. Thank you so much. Yes, Dr. Gulabi, good evening. Yes, lots of heart. Gaya, Sankaran, thank you so much. Now we understood about the intrinsic semiconductor. So this is the intrinsic semiconductor energy levels. Okay, when it is at 0 Kelvin, A la vanda 0 Kelvin. 0 Kelvin lanna it is act as an insulator. Insulator na adula free electrons edu illa. Appadina electrons ellam vandu in the valence band la irukku. Okay, now temperature increases. Appadina what will happen? Few electrons will move to the conduction band. Those who got the energy, it will move to the conduction band and it will create some empty space here. So, this is the energy level order diagram for intrinsic semiconductor. Understood? Got it everybody? Yes or no? Okay. Now we are going for the extrinsic semiconductor. Okay, we are going for the extrinsic semiconductor. So intrinsic level, as I mentioned, since it is pure, silicon na silicon, germanium na germanium, adu vandu konjam easy da. Okay, but the current produced in the intrinsic semiconductor vandu konjam kammi. Ana using extrinsic semiconductor we can produce a lot of current, and adukkaga what we are actually doing in the extrinsic semiconductor, we are actually adding impurities. We know that some pure-hearted people will be influenced by lot of naughty people, right? Exactly the similar way I can say that here we have the silicon, okay, we have the germanium. What will happen? They influenced by some impurities, and the impurities we will call it as dopants. Okay, we will call it as dopants, and the impurities we will call it as dopants. And the process when we add impurity to a pure silicon or to a pure germanium or to a pure semiconductor, we will call it as doping. The process the doping. So right now we have the doping process. Doping process na enna, the pure semiconductor la illana intrinsic semiconductor la vande impurities add pannu. Impurities add பண்ணும்போது இந்த conductivity rise ஆகும், conductivity will increase, and the process தான் doping. Okay, and the process தான் what we are calling it as doping. In the doping we will be using whatever be the impurities whatever we are adding, அது வந்து we will call it as dopants. Okay, whatever be the impurities whatever we are adding, adu vandu we will be call it as what? We will be call it as dopants. And in the dopants, while we are choosing the dopants, we should check the size of the particle and size of the dopant must be, it should at least comparable, and it is not supposed to take the major space of the crystal lattice, it not alter the structure, the crystal structure. So appadi konjam criteria irukku, ana vandu avlo important illa, anala you should know. Okay, the size should be comparable. Okay, the dopants oda size vandu and second one it is not supposed to distort the lattice of the crystal, and it is not supposed to take the majority, or let's say not supposed to take more space. Okay, this is we should mention in the doping. Okay, next one we are going for the extrinsic semiconductor. When we are doing doping with the intrinsic semiconductor, we will be getting extrinsic semiconductor. Okay, so in the extrinsic semiconductor we have two types of semiconductor, N type irukku, P type irukku. Okay, இப்போ we are adding a pentavalent. Okay, pentavalent na enna? Yes, in the valence electron 5. Pentavalent na valence electrons 5. Okay, valence electron 5. Okay, wow, correct. Okay, pentavalent na what? Yes, there is 5 valence electrons. Audio ke edachu problem irundha, just give me a text. Okay, just give me a text. Okay, so ipo 5 electrons irukku. In the 5 electrons, or let's say if we are adding pentavalent impurity na, we will be call it as N type semiconductor. Pentavalent na we are giving more electrons to the semiconductor. More electrons na more negative, appadina N type. புரிஞ்சுதா? இப்போ if we are using trivalent. Okay, trivalent na enna? Trivalent na enna? It is the valence electrons if we are adding a trivalent impurity to the silicon or the semiconductor, we will call it as P type. Understood? Everybody understood? Yes or no? Let me know in the chat box, please. Let me know in the chat box, please. Breaking again. Now it is sorted. Why? I don't know why it is breaking. இப்போ okay வா? Right now it's okay? Yes or no? Okay, okay. Okay, sorry for the inconvenience. Okay, perfect. Understood. Become a real one, I understood. Okay, yes, perfectly fine. Okay. Yes, sir. Yes. Okay, I think there won't be much problem. Let's see. So, இப்போ we are going for the N type. First we will be covering N type. N type na enna? We will be introducing pentavalent, right? We will be introducing pentavalent impurity to the pure silicon. Right? So, இப்போ இதுதான் நம்ம crystal. So, what will happen? I am giving a pentavalent impurity. Pentavalent impurity na and the valence electrons 5 இருக்கணும். So I am giving you a pentavalent impurity. அப்படினா first it will replace the silicon. Okay, so this is like it's our seat. Now what happened? Someone who came with more power, okay, what will happen? We will be replaced with that person. So now in the silicon what will happen? In the pentavalent impurity it will replace the silicon or germanium, or let's say the pure semiconductor, or let's say the pure crystal. Okay, இப்போ if I am introducing 5 pentavalent impurities, it will remove 5 silicons. Okay, இப்போ I am adding 1000 impurities, 1000 pentavalent impurities. Appadina what will happen? Yes, it will be producing 1000 it will remove 1000 silicons. Got it? So that's the first thing. So இப்போ we know that we are introducing a pentavalent, and we have 4 electrons to get, or let's say it will be creating covalent, but that is sorted. Now what will happen? There is one electron which is free. Okay, there is one electron which is free. Appadina what will happen? This free electron will leads to the current. If it is free now, it will move. That is what I said. If we are adding more impurities now, more free electrons will be there. 5 impurities now, 5 electrons will be there. So appadina I can say that in the case the majority charge carriers, Okay, the majority charge carriers it is nothing but majority charge carriers it is nothing but in the free electrons okay. So what it will do, it will replace the silicon, okay, it will replace the silicon, and definitely it will take the four electrons, and one will be free, okay, one will be free. And the free electron what will do, it will make Neet exam is going to be difficult, don't worry about it, okay, don't think it is going to be easy. First of all, again and again I'm just telling you, keep a mindset that this exam, this whatever be the exam, okay, it is going to be tough, because all the time if you wanted to come to the top level, okay, if you wanted to come to the top level, you should face difficulties, right? So in the exam also, exam la kuda if you wanted to come to the top level, difficult questions you have to face, okay, whatever it may be, maybe 2025 might be difficult, so adanala in the year vandu easy ah irukum, fine, aanalum there will be there will be some questions which will decide the ranks, and the ranks illa you should be there. It is not about I got rank 1 lakh 2 lakh, okay, that is not at all, okay, that is not at all acceptable. You should focus for I wanted to come in the first 100, adukkaga you should work, okay, purinjada everybody, okay, understood, okay. So ipo we understood that if we are giving 10 impurities, 10 free electrons will be there, adanala we will be call it as the same impurity as donor atom. Donor atom na enna, yeah, it is ready to give the electrons. Purinjada? Understood everybody, and major charge carriers vanta electrons da, fine, okay, major charge carriers vanta electrons da. So major, the current is due to the major charge carriers, that is nothing but electrons. And again, the question we can expect in the semiconductor vanta, you should study the concept only. Majority of the questions will be directly, it will be asked. Adanala the first question you can expect is, okay, now there is a free electron, okay, now there is a free electron, aanalum in the crystal vanda neutral, tell me the reason, okay, tell me the reason, there are free electrons now, right? So appo vanda you should tell me why still it is a neutral, tell me that. Tell me what might be the reason. This, even if this diagram I will draw very simply, even let's say if it is asked, usually it won't ask, but let's say draw some silicons, okay, and valency is nothing but 4, okay. So now this will be creating covalent bond, okay, covalent bond. Now you should just mark how it is making the covalent bond, that's it, nothing else. So it is not a big deal to draw this diagram, okay. And if it is a n-type semiconductor, it will be replaces with a pentavalent impurity, that's all, nothing else. So it is not at all a big deal, okay. So if I'm going to tell you why it is still a neutral, I mean still the solid crystal is neutral, since if there is one electron extra as well. So let me just say, even if there is a free electron, okay, even if there is a free electron, this becomes a positive ion, right? Again positive negative, it will become 0, it will become neutral, okay. So you should know, even if there is a free electron, intrinsic semiconductor lo kuda that is what we are saying, okay. So it is very simple, even if there is a free electron on the, I mean this pentavalent, this atom becomes an ion, so again the charges will become neutral, okay. Adu vanda romba important ana part, okay. Next vanda we are going for the energy band diagram. So idhila vanda we know that of course there will be electrons in the valence band, and it will be having some holes also, and it will go to the conduction band and the conductivity increases. And in the energy level vanda, it is nothing but the donor energy level. Okay, donor energy level, and the value vanda 0.01 electron volt. Idu da vanda in the energy level of the n-type semiconductor. Okay, we have the valence band, we have the conduction band, and just close to the conduction band, bottom of that we will be having the donor energy level as well. Now we can go for the trivalent. We are going for introducing trivalent impurity. So if you are introducing a trivalent impurity, what will happen? First of all, it will replace. I'm introducing an impurity, a trivalent impurity. Again, same as the n-type, it will replace the silicon. Okay, now it has replaced. Okay, and what will happen? It will be making bonds with the rest of the three, and there will be a vacant space. Okay, there will be a vacant space. Appadina, we can say that if I'm introducing a trivalent impurity, it will produce a hole. Now I'm telling you, if I'm introducing 100 trivalent impurities now, what will happen? It will produce 100 holes. Appadina, I can say that in this case, in the p-type, okay, in the p-type semiconductor lab, we will be using trivalent impurity. Okay, trivalent impurity, and also the major charge carriers. Nothing but the holes, and the impurity we will call it as acceptor atom. Understood? Everybody got it? Yes or no? No worries, you attend we are conducting the concept revision on Sunday and Monday. Sunday we will be doing half of the chapters, and Monday we will be completing the rest. So that will be completely concept revision. We are not going to do any questions there. Okay, just to practice, maybe we will be doing very few, and in the next day, Tuesday onwards, we will practice PYQs. Okay, so if you are attending these sessions, definitely I'm telling you, you will become more confident and you can score the maximum. Purinchida everybody? Yes or no? Okay, next one we have to focus on one law, mass action law. Idu one you should know the numericals can expect from this. So okay, numericals we can expect. So adu one very simple. We know in intrinsic semiconductor in the concentration of electrons is equal to the concentration of holes. Correct? Okay, in the intrinsic semiconductor concentration of holes, concentration of electrons also it's going to be equal. Appadina, if I'm doing n into nh, what will happen? If I'm saying this is the concentration Ni, appadina I can say that Ni square. Okay, so Ne, the concentration of electron into concentration of hole, which is equal to the concentration of intrinsic semiconductor square. Okay, so intrinsic semiconductor la electrons oda number holes oda number same. Appadina I'm just representing it as Ni. Okay, and if I'm multiplying this two, I'll be getting Ni square. Okay, and this is valid in extrinsic semiconductor also. If let's say you know the concentration in intrinsic semiconductor, okay, you know in the extrinsic semiconductor la in the holes oda illana electrons oda concentration kuda you know. Appadina what is NH? You can use this. Okay, understood everybody? So this is the important equation in this chapter. Ne, number, the concentration of electron, NH, the concentration of holes, okay, will be equal to Ni square. Ni na the concentration in the intrinsic semiconductor, which means on the intrinsic semiconductor what is the number of electrons, what is the number of holes. That is what. So this is important. Let us do a question based on this. Okay, and ingavanta, this is how the energy band of this trivalent. Whenever we are introducing the trivalent, we will be getting the energy band. Inga vanda in the acceptor energy level irukum, adoda value vanda 0.01 to 0.05 electron volt. Now we are going for the question. So I hope you will be doing within seconds. Calculation vanda avlo difficult adu illa. We have silicon, okay, we have silicon having 5 into 10 to the power 28 atoms per meter cube is doped with 1 parts per million concentration of antimony. Okay, 5 into 10 to the power 28 irukku. Question visible everybody? Okay, question visible everyone, for everybody? Okay, 5 into 10 to the power 28 atom per meter cube irukku, and that is doped with 1 parts per million concentration of antimony. If the concentration of holes in the doped crystal is 4.5, okay, idu vanda the concentration of holes, adu vanda 4.5 into 10 to the power 9 meter raised to minus 3. Those who are joined, please do like the video, share with your friends, also subscribe the channel for more such videos. Okay, so in the holes order concentration vanda 4.5 into 10 to the power 9. Then you should find what? You missed it. If the concentration of holes in the doped crystal is found to be this one, the concentration of intrinsic charge carriers in the silicon crystal is. Can you find it? Which equation we can use? Tell me which equation we can use in this case. Can I know in the chat box? Which equation we can use? We can go for the mass action law. It is nothing but Ne into Nh, which is equal to Ni square, and in this case we should find Ni. How we will be finding it? Tell me how we will be finding it. We have 5 into 10 to the power 28 atom per meter cube. Correct? Everybody? We have 5 into 10 to the power 28 atom. Everybody, how we will be doing it? Very simple calculation. Very simple calculation. You can do it and you will do it. No confusion in it. Correct? What is the answer? I'm not getting the answer in the chat box. Simple question da. As I mentioned, calculation kuda avlo difficult alla. So ipo vanta I'm going to explain. I didn't get any answers till now. Answer is B. Everybody is saying B. Yes, yes, yes. Come on, guys. So let us do it. Let us do it. How to do it? How to do it? How to do it? Tell me. Very good, very good, very good. Superb, guys, superb. Perfect. Okay, so we can see that we have a pure silicon crystal and it is having 5 into 10 to the power 28 atoms per meter cube is doped with 1 parts per million. Okay, so 1 donor வந்து 10 to the power 6 silicon. Okay, understood? Appadina we can say that Ne will be coming as what? Ne will be coming as 5 into 10 to the power 28 divided by 10 to the power 6. Purinjada everybody? Yes or no? Yes or no? Try it everybody. You can do it and you only doing it. one donor atom for 10 to the power 6 silicon. So we can say Ne vanta 5 into 10 to the power 28 divided by 10 to the power 26. Appadina holes concentration kuda we have. So we will be finding root of Ne NH. So we have the values, you can find it. Let me get the answer. Okay, no worries, no worries. This time you don't have to worry. Even if your pre-board is not that much good, this time for boards you can focus and you can make it. Okay, and the only thing is like you should be very much determined, and it is not about like I'm ready to study, I'm ready to study. You should study. There is no other way. Okay, so you guys have to. 10 to the power 28 divided by 10 to the power 6. Then it will be coming as 5 into 10 to the power 22. Okay. Done? Of course, yes. Let me tell you, the semiconductor chapter itself is a very big chapter. Like it's a high weightage chapter. 6 marks definitely you will be getting. Okay, you will definitely get 6 marks. Okay, and we are covering dual nature also. And as I mentioned, if possible, within the time limit, okay, if I could finish nuclei also, this 3 chapters will give you 15 marks. Okay, and ray optics, from the ray optics itself, you will be getting 10 to 12 marks. So now even you got the pass mark if you are just studying this few chapters. And I have done a video, what are the 5 chapters, 5 to 7 chapters you should focus to get 50 plus. Okay, so better you watch it and you will be getting it. Okay, so Ipavanta, we are going for the PN junction. What is PN junction? PN junction now we have the P type as well as the N type. Okay, Ipavanta, whenever we are just making it together, what will happen? This side, if I'm saying about this P type, sorry, we have the N type and this P type. What will happen, guys? What will happen? Yes, this electron hole recombination will happen. Okay, electron hole recombination will happen. So when I'm talking about PN junction, there will be N type as well as P type semiconductor, and there will be electron hole recombination. So this is the first sentence. When you heard PN junction, the first sentence you should write as nothing but the our electron hole recombination. Understood? Got it? So right now we just wanted to see what is exactly happening in this. Okay, how 10 to the power minus 6? Hey, it is mentioned parts per million. 5 into 10 to the power 28 what was the sentence given? 5 into 10 to the power 28 atoms per meter cube is doped with 1 parts per million concentration of antimony, which means 1 donor atom for 10 to the power 6 silicon. Okay, 1 donor atom for 10 to the power 6 silicon. Appadina for 1 silicon we can just divide it with 10 to the power 6. That's it. Okay, done. Yes, very good Shankaran. Okay, so Ipavanta, we have studied about the PN junction. So in the PN junction lavanta, definitely the electron hole recombination will happen. So appadina you can just imagine first there will be some electrons coming here and this recombination will happen. So gradually what will happen? There will be a layer will be formed, and that layer is known as depletion layer. Okay, so in the electron hole recombination, it will happen. Okay, and the time there will be a potential barrier will be developed, and we will call it as depletion region or depletion line. So what will happen later? So now there is a depletion layer. Okay, so ipo vanda it will be like this. Okay, I have missed it, I guess. Okay, so after some time, if I'm just focusing over this, where the center portion, we can see that there will be the negative charges over here, and there will be more positive charges over here. Okay, this become more positive and this become more negative. Appadina, we can't say that there will be electrons. I mean, it will try to oppose, or let's say it will resist the the flow of electrons. Okay, so ipo the flow smooth. Okay, electrons n type la irukkiradhu, we know that more on electrons. So on the electrons in the p side lo varum, because this is positive side, so it will be get attracted. Okay, and in the p side la what will happen, there are more holes, and the holes in the electrons oda attract agum. It will come close. Okay, so it will happen after some time this will become more negative. Appo in the electrons it cannot come here. Okay, and this side la irundha in the positive kuda it cannot pass. ஏன்னா அந்த depletion layer big arch, or let's say potential barrier big arch, so it needs more potential to overcome this depletion region. Understood? So positive and negative layers will be formed. Adanala in the electrons holes after some time it cannot cross each other, or let's say it cannot move to the other end. Appadina, what will happen in the depletion layer nala, and the current flow due to this charge carriers won't happen. So till this depletion layer become bigger, and to stop till that point there is a current due to this electron and hole motion, right? The electrons will be moving here, and holes will be moving here. Appadina, what will happen due to this flow? Okay, due to this flow there will be a current, and that current is nothing but diffusion current. Okay, this is called as the diffusion current. I will also call it as the current due to major charge carriers. Correct or wrong? Okay, it is nothing but the major charge carriers. Got it? Everybody understood? Yes or no? Okay, yes or no? So ipo we have n type, we have p type. So when we are making them when this p-n junction comes up, what will happen? In the n side la irundha electrons will be moving towards p side. Holes p side la irundha n side lotum, it will move towards n side as well. Okay, appadina what will happen? There will be a current due to the major charge carriers. Yena n type la major charge carriers electrons, p type la major charge carriers holes. So this is due to the major charge carriers. Adanala I will call it as diffusion current. Okay, so now what happened? Due to this depletion layer there is a electric field. Okay, there is a electric field formed across this depletion layer. So what happened right now? There is a electric field across the depletion region. Okay, depletion region. So due to this electric field there is an advantage for the minority charge carriers. Okay, in the electric field nala, in the minority charge carriers it will start flow. Okay, flow of minority charge carriers. Okay, purinjada? So right now there is an electric field and there is a flow of minority charge carriers, and definitely sometimes you will think like, okay, in n types semiconductor, from where we got this holes, right? Minority na n type la holes da, right? And that is due to, because we know that whenever we are doing this doping, because this is very, very important, listen, okay, whenever we are talking about N type, whenever we are talking about P type, we are adding the impurities, right? We are adding the impurities. And the process we should give a lot of temperature, okay? And adoda effect, even in N type, we will be having the holes, okay? In P type, we can see electrons as well. So, what I'm saying is like, when this P junction comes, there will be a flow due to the minority charge carriers, and the minority charge carriers will flow the what we are saying the drift current. Okay, that is nothing but drift current. So, இப்போ வந்து PN junction la we have two types of current. First வந்து diffusion current. Okay, first வந்து diffusion current. அதோட reason என்ன? Major charge carriers will flow. Okay, major charge carriers will flow. அதனால we can say this diffusion current is nothing but the current due to major charge carriers. இப்போ வந்து I'm talking about drift current. Drift current na என்ன? Minority charge carriers. It is due to the minority flow of minority charge carriers, which means P type la irundha electrons towards N type and N type la irundha holes vanda towards P side. Adutha in the flow. And initially vanda in the diffusion current vanda romba adhigama irukum. Okay, diffusion current vanda romba adhigama irukum. Ana later the depletion layer width increases and the diffusion current oda amount vanda it is going to reduce. Okay, and the drift current it will be equal to the diffusion current. And the time we can say that there won't be any flow from this N type, I mean electrons from N type and holes from P type. Okay, Purinjada, everybody understood? Everybody understood? Yes or no? Please let me know in the chat box. Please let me know on the chat box. Yes, very good, very good, very good. So, now we have PN junction. What is happening there? It is nothing but electron hole recombination. And idhila we know in the beginning there will be electrons from N side and holes from P side will be moving in the directions. Okay? Appadina there will be diffusion current. Adu due to majority charge carriers. And there will be an electric field formed due to this depletion layer. Adanala vantha the minority charge carriers, which means the holes from P side will move to N side. Electrons from P side will be moving towards N side, and holes from again is missed. Okay. Again, come back. Okay. So right now P type la vanda minority charge carriers electrons. Okay. And the electrons it will move towards N side. Correct? Okay. Now I'm talking about N type. N type la vanda holes the minority. Okay. N type la vanda holes minority. So in the minority charge carriers will be moving towards. Got it? So this is what actually happening. So adanala we will be getting drift current. And at some point in the two currents same agapore. So at the moment the depletion layer formed completely. And for silicon, okay, and for this value is very, very important. Silicon and the value, the potential, the barrier potential 0.7 volt. Germanium 0.3 volt. Okay, Purinjada, these values are very important. So when the flow of the majority charge carriers will happen and there is a barrier potential, after that there won't be any flow of majority charge carriers, and on the voltage and the barrier potential silicon 0.7 and germanium 0.3. Understood? Holes, I mean in the depletion layer form pandrathu in the electron hole recombination. It will be coming closer, and then one side will become more negative. It won't allow more electrons, or let's say it won't be allowing more electrons. This side is becoming more negative. So that there will be a repulsion. Okay, so it is due to the electron hole recombination. Okay, wow, very good. Now we are going for the PN junction diode. Okay, so PN junction in the junction we will be keeping two metallic plates. Okay, then we will be call it as PN junction diode. Okay, we will be giving two metallic plate. So in the PN junction we can give potential. Okay, but we can give potential, or let's say we can connect it with a battery. Adudha we are calling it as biasing. Okay, so right now we have forward bias as well as reverse bias. Okay, right now we have two things to study: forward bias and reverse bias. Are you guys ready? Okay, so don't worry, numericals we will be solving on from Wednesday onwards. As I mentioned, Tuesday onwards we will be keeping classes for the PYQ numericals expected questions. Till your exam date we will be covering questions only. Ana you are not supposed to miss the Sunday and Monday class concept revision. It is going to be a marathon. You guys have to be there. Okay, adula compromise illa. And the two classes, if you are watching, you can do all the PYQs and all the rest of the things. Adanala da solra, everyone should attend the class on Sunday and Monday. Full concept revision da, and the concept revision romba important. Yena without concept we cannot do anything. Okay, next days we will be practicing PYQs, especially numericals. I know you people are struggling to solve numericals. No worries, I will help you, don't worry about it. Okay, wow, fine. Everybody? Okay, wow? Okay, so now the forward biasing. So now we can just mention, or let's say we can represent a PN junction diode like this. Okay, this is the positive side, this is the negative side. Okay, positive and negative. Okay, so you can just see this is positive and coming towards here it becomes narrowing, so that is going to be negative. You can just think like that. Okay, now we have a diode. In the diode positive and negative we have connected like this. Then we will be call it as this is forward biased. In the forward bias layer, what will happen in the width of depletion layer? Okay, width of depletion layer it will reduce. Understood? Depletion layer the width reduce agapore. Appadina and the potential barrier and the value kuda decrease agum. Purinjada? Ipo I am going to giving a voltage supply to this diode. Okay, now what happened? The depletion layer is formed. Okay, we know it is formed. And right now, what we are doing, we are giving a battery. So, when we are applying, when we are connecting with the battery, what is exactly happening? Yes, if the whatever be the potential we are providing, let me say the external, whatever be the potential we are providing here, if it is greater than the potential barrier, okay, we have mentioned silicon 0.7. If I am giving, let's say if it is of a silicon, I can say that if I am giving a potential more than 0.7, what will happen, guys? What will happen? Again, the electrons and hole is getting more energy to overcome the depletion layer. Understood? So, in forward bias, the depletion layer, due to the depletion layer, there is a potential barrier, and for silicon it is 0.7 and germanium it is 0.3. Now I am giving a potential which is more than this potential barrier, and the electrons and holes again it will start flowing across the potential barrier. Understood? Get it or what? Okay, so idu romba important ana thing. Okay va, yes or no? Okay. Timing of next class most probably it is on Thursday. Okay, tomorrow there won't be any class for physics. I think chemistry and biology will be there, and for physics we will be covering ray optics and wave optics on Thursday at 5 o'clock. Okay, adu 4 hours class agapore. Understood? So you can, if you are facing issues with ray optics and wave optics, you can attend the session. We will solve numericals also in that session. And as I mentioned, again we will be mostly meet on this I think on Sunday and Monday. So till that you have to prepare yourself, and we are going for the marathon we are not going to take rest from Sunday onwards. Got it? When the session will end, when it finishes, we will. Okay. So actually, I have some health issue. Adanalada in the class it was scheduled for 5, and we again made it to 6. Konja health issues tha. So I too wanted to finish this class as soon as possible. Okay. Okay va? So ipo we have seen the forward bias. Forward bias the positive will be connecting to the positive terminal of the battery, and negative region the negative side of the battery we will be connecting, and the depletion layer, if you are giving the potential more than the barrier potential, there will be again the electron hole pair, hole flow will be there, and we will be call it as the the ejected electrons, okay, and this is what the width of the depletion layer and potential barrier. So you can just see that when the voltage increases, okay, when the voltage increases, what exactly happening? The depletion layer it is decreasing. The external potential whatever we are giving through the battery, if it is increases, and the depletion layer konjam kammi agapore. So this is what I said, this is what ejected electrons and ejected holes. It is due to the external potential whatever we are applied. Okay, it stops actually the charges the flow stop achu. Analum when we are giving the potential, again the flow will happen, and we will say ejected electrons and ejected holes. Fine. So next in the graph very important. Okay, the VI characteristics of forward biasing. So idhila you can see that the potential is here in the x-axis, and in the current given in the y-axis, and you should check this is given in the milliampere. In the VI characteristic rompa important concept da. So inga you can just see that the current is given in milliampere and the potential is given in the x-axis. Now you can see that the potential till, this is for silicon, okay, this is for silicon, till 0.7 there is no current at all, okay. I am connecting a battery, so I am giving 0.1 volt, no current flow, or let's say no charges. Charges are not moving, okay. If I am giving 0.2, no way. If I am giving 0.4, no way. If I am giving 0.6, no way. If I am giving more than 0.7 for the silicon diode, what will happen? Yes, again the flow will happen. So appadina there will be a current flow, okay, there will be a rapid current flow, and that is in milliampere, okay. There will be a rapid current flow, or I can just say that the current will increase exponentially. This is a graph representing the exponent function, right? So the current will be increasing exponentially, okay. So the current will be increasing exponentially, or let's say you can see that the current will increase sharply when we are giving a potential more than the barrier potential. We will be getting the VI graph like this. Understood? Yes or no? Can I get yes in the chat box? This is actually for 2 chapters. We will be covering semiconductors. I think we have the rectifier and reverse bias left. After that we will be going for dual nature. Okay, because 2 chapters are having a good weightage. Okay. As I mentioned, no PYQs we will be solving from Tuesday onwards. Okay, so now we have reverse biasing. Okay, reverse biasing and forward biasing la we have connected positive to positive. So reverse bias na enna positive and the negative. Okay, positive will be connected with the negative terminal of the battery. Okay, then we will say it is nothing but reverse biasing. So reverse biasing la whatever happened in the forward bias, exactly opposite will happen. The width of the depletion layer again increases. Correct. Again the depletion layer increases, the width increases, barrier potential also increases. We are again and again, we have connected with the battery, right? I am increasing the potential, I am increasing the potential. It will go up to some point. At some point, then the diode will become damaged. Okay, so whenever we are connecting a diode, in reverse bias, what will happen? The depletion layer oda width வந்து increase ஆகும், barrier potential வந்து இன்னும் அதிகமாக போறே. So usually if I'm saying about this, I can say that this potential I'm increasing. At some point the diode gone. Okay, and the time we will call, I mean the voltage which the diode becomes damaged, that voltage we will be call it as breakdown voltage. Okay, we will call it as breakdown voltage, and the breakdown voltage recharge na, there will be a sharp flow of current, there will be a high amount of current, even it is even less than the previous case in the forward bias. This is going to be in microampere, analum sharpa we can see a current flow in the breakdown region. Okay, and you can see one more thing here. If I'm just checking on the graph, the values van the 0.2, 0.4, 0.4. Okay, the potential van the 0.2, 0.4. Ana van the in the graph la if you are just seeing 20, 40, 60, 80. Okay, 80 kapram da in the breakdown region varudhu. Okay, 80 volt oda plus 80 volt da in the breakdown region varudhu, and the current will be in microampere. Understood? So this is what we need to study in the reverse bias. So we have two types, forward bias and reverse bias. In the forward bias la vanda what we have studied, forward bias la the depletion width vanda reduce agum, potential vanda reduce agum, and if you are giving a potential more than the barrier potential, again the electron and this whole motion will happen, there will be a current flow. Okay, adu vanda milliampere la tha. So for a silicon you should give a potential that is more than 0.7, and for germanium you should give more than 0.3. Okay, adukapram we have studied the reverse biasing. In the reverse biasing la vandu what is happening? In the reverse biasing la when we I mean this is how it is connected, negative to the positive and positive to the negative, and the depletion width vandu innu increase aga pore. So when we are increasing the potential whatever we are giving, what will happen? At some point it will damage the diode, and the voltage, the breakdown voltage. Okay, and the breakdown voltage la vandu sharpa in the current increase aga pore. Okay, so now we are going for the rectifier. Rectifier na it is nothing but a device which is used to convert AC to DC. Whatever be the devices we are using, adla vanda we are using rectifier. Yena and the devices vandu work pandrathu DC la. Okay, so in the AC DC akra process the rectification. Okay, adoda device we will call it as rectifier. So ipo vanda we have two types of rectifiers. First one the half wave rectifier, and second one the full wave rectifier. So first let us go for the half wave rectifier. So idala structure enna, we will be giving the potential, and we will be having a step down transformer, and we will be connecting one end to the diode which is in the forward bias, and we will be connecting to the external circuit, or let's say whatever be the device we need to connect. If you need to connect whatever be the device, if it is a bulb, whatever it may be, we will be connecting over here. This is the device where we need to connect. Okay, so if what will happen? The one which is coming is AC, the voltage which is coming is AC. Okay, so if the first positive cycle AC na ippadida, right? AC vanda ippadida. Okay, so first one I'm talking about the positive half cycle. Okay, and the positive half cycle what will happen? This is forward biased, right? So if it is forward biased, it will make this positive half cycle to allow, I mean it is unidirectional in the what to say rectifier one the unidirectional, so it will allow this positive half cycle. Okay, ipo one I'm talking about the second part. Okay, the negative half cycle. Okay, negative half cycle na enagum, it is unidirectional, right? So if it is reaches on this forward bias diode, what will happen? It won't allow the flow. Okay, it won't allow the voltage. So appadina there won't be any output here. Next one, again we will be having the positive cycle, again we will be getting the result, again after that what will happen, negative cycle will come, it won't allow that to passes through the diode, so there won't be any current reaching the device, so always we will be getting the positive half cycles only. Okay, so in the half wave rectifier la vanda, the AC voltage when it is reaches here, only it will allow the positive cycles. Understood? So adanala vanda we won't be getting the maximum output, the what is it, the percentage. Okay, the effect vanda, it is nothing but 40.6, yeah, 40.6% the idoda efficiency. Okay, and frequency vanda same, output oda frequency input oda frequency vanda same. So half wave rectifier la vanda you should know where, I mean it will only allow the positive half cycles, yena in the direct diode vanda unidirectional, and the efficiency vanda 40.6%, and the input frequency will be equal to the output frequency. Okay, இப்போ வந்து we are going for the full wave rectifier. Full wave rectifier la vanda we will be using a center tapped transformer. ஏனா we need to shift, okay, we need a 180-degree phase change over there. Okay, so இப்போ வந்து we have a center tapped transformer. Idhila vanda we have connected a diode here, we have connected a diode over here as well, and from this center we have all we have done the earthing, as well as we are taking the output, the device also we are connecting with the center tap connection. Okay, purinjada? So ipo vanda we are going to discuss, let us say we have the cycle comes here. Okay, so ipo vanda the way, the voltage vanda ippadida. Okay, it is AC only, and what is going to be the input here, there will be a 180-degree phase change. Appadina this is how it looks. Okay, so ipo vanda we have a 180-degree phase change in this area. So what will happen, first vanda we are going to consider the positive half cycle. No issues, it will let's say this is the AC that we have, and in the right now it will allow the positive half. No worries, we will be getting the positive half. Okay, ana inge what will happen, this is negative and this is forward biased, so there won't be any flow which is happening through the second diode. Ana vanta right now here what is happening, negative half cycle, no result. Okay, it won't allow, and ana vandu inge there is a 180-degree phase change, right? So this will be again giving you the result. So idu vandu highly efficient, the efficiency vandu 80.2% da idoda efficiency, and frequency vandu 2 times than that of the input frequency. Okay, frequency the frequency of output 2 times input frequency. Purinjada everybody? Okay, yes or no? So ipo we have studied about the full wave rectifier. Again I want to tell you one thing, if you wanted to get distracted, this is not the place for you. Okay, you can focus because we are going to get maximum score. Adukagata we are conducting the class and few students are coming. Okay, so if you want to attend, you can. Okay, the rest of the things we can discuss later. Idu vanda CBSE exam oda focus la we are studying. Okay, so now on the full wave rectifier la vanda we are using center tapped transformer to get a 180-degree phase shift. Okay, and in each half cycle what is happening, the input when it is positive half cycle is coming over here, the first diode will be giving you the output. Okay, when it is the negative half cycle, it will be the second diode will be giving you the result. So ipo vanda we will be getting a full wave rectifier, and the efficiency vanda 80.2%. Okay, so idu vanda important ana topic da. And also next vanda, as I said, this is how we are getting the output, which means the AC ripples are still there. If you wanted to remove that ripples, either you can connect a capacitor parallelly or you can connect an inductor in series. Okay, so we can go for, to avoid the ripples of AC, you can do one thing, you can connect a capacitor parallel to the device, okay? Otherwise, you can connect a inductor series to the device. Purinjada everybody? Yes or no? Yes or no? Got it? Okay? So now Anta, we have understood the major part of the semiconductor, and now we are just going for a 10 minutes break, just hardly 10 minutes. We will be back at 7:35. Okay, we will resume at 7:35 and we will continue with the dual nature. Okay. So in dual nature, we will be covering all the concepts, everything. So guys, just wait for 10 minutes. Let's have a small break. After that, we can again come. Okay, see you. Hi all. Hi everybody, am I audible? Please let me know. Am I audible? Video, audio, everything is perfect. Perfectly perfect. Please let me know, guys. Yes, perfect. So let us just start with the dual nature. Okay, so before that I just wanted to tell you, as I mentioned, don't forget to like. Also subscribe the channel. We are doing a lots of videos. As I mentioned, every chapter I am planning to do a 10 minutes rapid revision, so that will definitely help you for during the exam, the last minute it will help you. So for all those things you guys have to subscribe the channel. Also share with your friends, because with us they also supposed to study, right? Yes or no? Okay, so let us just continue with the dual nature. Okay, anyway, I am not continuing nuclei and I don't think I can finish today. As I mentioned, I have some health issues, so we will finish the dual nature. And as I mentioned, Sunday we are going to finish the entire physics, the complete physics we will finish in Sunday and Monday, and the 2 days we will become pro in physics. I am telling you, just believe me. Okay, wow, everybody is okay? Please let me know on the chat box. Say okay. Okay, wow. Okay. I will do chapter 2 also. Don't worry, guys. Oh my god, I don't know what is the trouble with chapter 2. If possible, I will take in the next day also. Let me just check. As I mentioned, I too have some work to finish. I couldn't make it. Okay, so even I couldn't. Sunday we are going to finish it. Electric potential and capacitance finish pandradhukku we will go for any other chapter. Okay, va. Tomorrow on the physics, it is not going to be there. Rest day for me. Okay. Okay. So you guys can, I think you will be having chemistry and biology. Ana physics vanta Thursday, Friday la irukum. So you guys have to come on 5. Okay. Thursday la irundha 5 on time I will come. So we are going for dual nature. Okay. Dual nature na and the name la irukku dual. Okay, so dual na enna? Yes, if you are talking about edachu audio video problem irundha, you just mention in the chat. Okay, fine. Okay, so ipo we are going for, we have studied ray optics, we have studied wave optics. Adula irundha we understood that light ku two properties irukku. Wave, it is also behave as wave. In the particle kuda Tamil it's weak. It is getting weak. Okay, so what is that? Dual nature. Light ku wave nature irukku, particle nature kuda irukku. Okay, so ipo we are going to discuss about the particle nature of this light. Okay, so ipo we have photons. Okay, I'll start with photons because you guys already know what is photon and all. So photon na enna? It is an energy packet. Okay, it is an energy packet. Okay, so adukku we cannot define the mass, we cannot touch. Whatever we are feeling, we are exactly feeling the photons. We cannot see, we cannot just hold it and we can, oh, this is what a photon. We cannot. Okay, photon it will travel with the speed of light, means it will travel with 3 into 10 to the power 8. Okay, in the photon it is not something like our electron, proton and all. The common characteristics irukku, ana rendum same alla, it is going to be different. Okay, va? Of course, I will do. You don't have to worry about it. Okay? Okay, va? Okay. So now we were discussing about photon. Photon now we cannot see, we can experience, we can feel it. Okay, and also it is moving with the speed of light, and also it is having momentum. Okay, it is having energy, and the energy வந்து equal to h mu. Okay, h na enna Planck's constant, mu na enna frequency. So appo we can say that when frequency increases, in the energy increase aga pora, ena h வந்து constant. Okay, also we can see that this mu na enna we already studied mu is equal to c by, or let's say velocity by lambda. So I can again replace and I will be getting hc by lambda. So energy of a photon na, it is nothing but hc by lambda, and the h oda value வந்து 6.62 into 10 to the power minus 34. H oda value வந்து 6.6 into 10 to the power minus 34. அதோட unit na enna? It is coming as joule per second. Yeah, because we know that E is equal to h nu, right? E is equal to h mu. So E by mu is nothing but h. Appadina we can say E divided by mu na second inverse. Okay, so appo we will be getting the h value. Yes, weightage of dual, we cannot just simply say this is the weightage, it will vary. Okay, I can say semiconductor it will definitely ask for 5 to 6 marks. Okay, it will ask for 5 to 6 marks. Got it. So ipo vanda we have seen the h value vanda 6.6 into 10 to the power minus 34 joule second. Okay, because we can see that here one the joules, idu one the frequency na s inverse, so it will come in the top and it will become joule second. Okay, so don't forget about the unit, it is 6.64 into 10 to the power minus 34 joule second. Understood? Okay, so ipo vanda when I'm saying intensity of photon increases, which means we have a bright light. Okay, ipo vanda bright light vara. Okay, appadina I can say intensity vanda it is more. Appadina I can say the number of photons vanda more. Okay, ipo vanda we are discussing about photons. We know the rest mass vanda zero da. Okay, and we cannot hold it. It is not something like electron, proton. Okay, it will be having common characteristics. It will travel with the speed as 3 into 10 to the power 8 meter per second. And adorku energy irukku, momentum irukku, and the energy vanda h mu na, that is nothing but h vanda Planck's constant, mu vanda frequency. So when we are increasing the frequency, what is happening with the energy of the photon? It will increase. Ipo vanda I am giving more wavelength. Okay, listen, frequency increase na energy is more. Ipo vanda I am talking about wavelength lambda. Ipo I am taking a wavelength which is which have a longer wavelength. Appadina adukku vanda energy kammi da. Yena lambda inversely proportional. Hc constant, c na 3 into 10 to the power 8. H vanda constant, Planck's constant. Appadina energy vanda proportional to 1 by lambda. Appo vanda lambda increase ana energy vanda decrease agum. Purinjada everybody understood? Ipo vanda we have energy will increase when frequency increases, and energy will decrease when the wavelength increases. Okay, now vanda bright light na number of photons vanda adhigama irukum, dim light na number of photons vanda less irukum. Purinjada? At least you should know this basic things about the photon. Now we can just go for the important part, that is nothing but first we will be starting with the emission. So emission la vanda first vanda thermionic emission na enna? Emission na we need to take electron out. Okay, for adukkaga in the electron ku konjam energy kadaikanum. Okay, if we are just without having anything, if we are just lying on the bed, what will happen? We will just lie. But let's say whenever you're getting some biryani, whenever you're getting some good food, what will happen? You will just wake up, we will run, we will jump, right? So exactly the similar way in the electronics, electronic vandu konjam energy veno, and the energy in different format we can give. Okay, right now what I'm doing, I'm giving heat. அப்படினா அந்த heat energy யூஸ் பண்ணி இந்த electron escape ஆகும். ஓகே, அந்த எமிஷன், அந்த எலக்ட்ரானோட எமிஷன், இப்போ வந்து ஒரு சர்ஃபேஸில் நிறைய எலக்ட்ரான்ஸ் இருக்குது. இப்போ வந்து ஐம் ஹீட்டிங் த சர்ஃபேஸ். அப்போ வாட் வில் ஹேப்பன், த எலக்ட்ரான்ஸ் வந்து எமிட் ஆகும். ஓகே, ஸோ இஃப் ஐம் யூசிங் ஹீட், அந்த எமிஷனோட பேர் தான் தெர்மியானிக் எமிஷன். தெர்மியானிக் எமிஷன்னா என்ன? The heat, I mean the electron emission is due to the heat energy that we are giving. Next one, the field emission. Now you can just define field emission. Field emission na enna? Field emission na enna? Yes, when we are giving high electric field, then this electron again escape, or let's say it will emit from the surface. Appadina we will call it as field emission. Ipo vandu innum important ana in the chapter oda major portion, that is nothing but the photoelectric effect. Okay, so ipo vandu we should know what is photoelectric effect. Photoelectric effect என்னன்னா, இப்போ வந்து previous caseல we have given thermal energy, we have given field, strong field. இப்போ வந்து I'm giving light. So let's say if I'm having a metal surface over here, இதில் வந்து many electrons இருக்கு. Okay, அப்படின்னா இப்போ வந்து light வந்து இந்த surfaceல it will fall on the surface. அந்த light energy யூஸ் பண்ணி இந்த electrons emit ஆக போற அந்த process ஓட name தான் photoelectric effect, photoelectric emission, using the what is the energy from the light. Okay, and I will more specifically I will say with the suitable frequency la. Okay, and the light க்கு வந்து suitable frequency இருக்கணும். Suitable frequency na, and the frequency there will be a minimum value. Okay, and the minimum value oda adhigama irundha mattunda in the emission possible agum. Okay, let me repeat again. Light is falling on the metal surface, fine, no worries, light is falling on the metal surface. Okay, so ipo vandu in the electron emit aganumna, it is not about dim light or bright light, and the frequency வந்து கொஞ்சம் ஹையா இருக்கணும். ஓகே, அப்போ வந்து ஒரு மெட்டல் சர்ஃபேஸுக்கு வந்து, ஆர் லெட்ஸ் ஐ கேன் சே ஒரு எலக்ட்ரானுக்கு வந்து இந்த லைட்ல இருந்து வர ஃபோட்டோன் தான். ஓகே, இப்போ வந்து இந்த லைட்ல ஃபோட்டோன்ஸ் இருக்கும். ஃபோட்டோன்ஸ்னா என்ன? எனர்ஜி பேக்கெட்ஸ், கரெக்டா? ஸோ அது வந்து எனர்ஜி பேக்கெட்ஸ் தான். Any problem? Okay, very good. Okay, so in the energy packets வந்து இந்த எலக்ட்ரானோட interact பண்ணும். So on the interaction la, that electron will gain the energy, the h mu energy, and the h mu energy sufficient na in the electron emitter. Okay, so it is not about any light is coming and falling. With the suitable frequency, with the means a suitable energy. Okay, with the suitable energy in the photons vanda in the electron la hit பண்ணும்போது இந்த electron and the energy use பண்ணி it will escape. Okay, so photoelectric effect na enna? The light with suitable frequency, falls on a surface. Okay, falls on a metal surface, and the photons will interact with the electron and it will escape from the metal surface. And one important thing enna na, one electron ku vandu one photon. Okay, so one photon can interact with one electron only. Understood? Yes or no? Please let me know in the chat box, please. இப்போ வந்து ஒரு ஃபோட்டோனுக்கு வந்து ஒரு எலக்ட்ரான். Okay, it can interact with only one electron. Okay, understood? Got it? Now we are going for a experiment. Are you guys excited for this experiment? Let me know on the chat box, please. Are you guys ready for the experiment? So in the experiment la vanda, we have a evacuated glass tube, no air particles, nothing. Okay, so the light vanda it will falls on a metal plate. Okay, and the metal plate oda per da emitter plate. Okay, photosensitive emitter plate, புரிஞ்சுதா? இது வந்து photosensitive emitter plate. So இந்த light வந்து directா இந்த plateல வந்து hit ஆகும். So இந்த பிளேட்ல வந்து free electrons இருக்கு புரிஞ்சுதா இந்த லைட்ல வந்து free electrons இருக்கு அப்படினா இதுல இருக்கிற இந்த லைட்ல இருக்கிற photons வந்து each electron ஓட interact ஆகும் and definitely it will if it is sufficient if the electron get the sufficient energy அதுதான் important இந்த electron இந்த photosensitive plate ல இருக்கிற electronக்கு sufficient energy கிடைச்சா what it will do it will move towards A ஏனா அதுக்கு வேற வழியே இல்ல okay ஆனா இந்த A வந்து negative plate தான் it is connected with the negative plate அப்படினா negative okay it will be connected with it so இது வந்து it will attract all the electrons and it will follow அதுக்கு வேற வழியே இல்ல அதனால it will just come here okay இப்போ வந்து we have a commutator here அது வந்து it is just to reverse the direction of battery nothing else okay and also we will be having a voltmeter as well as ammeter to measure okay so இதுதான் நம்ம experimental setup we have a glass evacuated tube okay other we don't want any other ions or particles inside the evacuated glass okay and photosensitive plate irukum light it will directly fall on the metal plate in the energy sufficient na ovvoru electrons ikum I mean for one electron one photon will interact with one electron and that one electron will move okay next வந்து another photon will come it will interact with another electron and that electron will also flow so இப்படி இந்த flow I mean due to that there will be a current இப்போ வந்து the whatever we have discussed in the beginning okay we said when intensity if I am saying intensity bright light intensity increases which means bright light na number of photons வந்து அதிகமா இருக்கும் yes or no that is what we have discussed let me know in the chat box yes or no yes of course okay yes or no tell me so இப்போ வந்து intensity அதிகமா இருந்தா number of photons அதிகமா இருக்கும் number of photons அதிகமானா the number of electrons in the photons வந்து it will interact with the electrons okay so I can say okay number of photons அதிகமானா we can say the number of electrons emitted வந்து it is going to be more okay intensity bright light number of photons more and for one photon one electron அப்படினா 5 photons na 5 electron 10 photons na 10 electrons அப்படினா number of photons increase பண்ணினா number of electrons emitted will increase அப்படினா இந்த electrons ஓட flow ல we will be getting a current அந்த current தான் photo current அந்த current தான் photo current அந்த photo current கூட increase ஆக போறே understood don't forget to like share with your friends we are studying this chapter we will finish this chapter and you will be happy after this okay so intensity வந்து increase ஆனா number of photons அதிகம் number of photons na ஒரு photon ஒரு electron one photon க்கு one electron அப்படினா number of photons increases number of electrons ejected number of electrons emitted will increase அப்படினா we can say the current will be more the photo current will be more அப்படினா I am going to make a relation intensity வந்து proportional to photo current okay intensity வந்து photo current க்கு proportional ஆக போறே are you getting it yes or no audio now it's sorted yes or no because it is fell down I'm really sorry now it is okay yes or no please let me know in the chat box yes okay thank you okay thank you fine let's continue okay So now we understood in the intensity the photo current proportional as I mentioned. Intensity, brightness increases, number of photons increases, number of electrons emitted increases, and electrons would flow the current. So in the case we will call it as photo current. This is because of photoelectric effect. Okay, appo we can say intensity proportional to fine, okay, proportional to photo current. Okay, இப்போ we are going to discuss about frequency. Okay, so frequency அதிகமா இருந்தா what we will say, energy high. Okay, frequency அதிகமா இருந்தா energy high. So இப்போ we should know one thing, whenever we are talking about an electron, இந்த electronக்கு இந்த what is it, to escape from the metal surface அதுக்கு ஒரு minimum energy வேணும். Okay, adukku oru minimum energy venum. Last class la kuda we have explained this. Adu da work function. What is this? Work function. Work function na enna? The minimum energy. Okay, the minimum energy required for an electron to escape from the surface. Okay, minimum energy. Okay, so இப்போ in the light whatever be the light coming, whether it is dim or bright, that doesn't matter. And the light or let's say and the photon in the minimum energy இருக்கணும். இல்லனா let's say in the electron it needs 5 energy. Okay, it needs 5 unit energy. ஆனா light la photon இருக்குறது 4 units energy தான். அப்படினா இந்த electronக்கு it is not getting the sufficient energy. அதனாலதா I have already told you when we were discussing about photoelectric effect, with the suitable frequency. What is the suitable frequency? இந்த electronக்கு sufficient ஆன energy கிடைக்கணும். Sufficient ஆன energy na what is the meaning? Sufficient ஆன frequency இருக்கணும். அப்படினா we can say whenever we have an electron, whenever we have a photon and the photon க்கு energy which is more than the work function என்ன இந்த electronக்கு தேவையான energy. So இந்த work function விட அதிகமா இருந்தா இந்த electronக்கு அந்த energy யூஸ் பண்ணி escape பண்ண முடியும். புரிஞ்சுதா? Yes or no? Yes or no? Yes or no? Yes or no? Got it? Please let me know in the chat box, please. Okay, so right now frequency increase ஆச்சு, energy increase ஆச்சு. அப்படினா அந்த photonோட energy அதிகம், so electronக்கு sufficient energy கிடைக்கும். அந்த minimum energy which required for an electron, we said it is work function. அப்போ we have to define one more thing. அது threshold frequency. என்னது? Threshold frequency. இந்த work function கிடைக்கிறதுக்கு, okay, இந்த work function கிடைக்கிறதுக்கு அந்த photonக்கு ஒரு minimum frequency இருக்கணும். அந்த minimum frequencyல அந்த minimum frequency தான் we will be call it as threshold frequency. So இந்த photonக்கு இந்த threshold frequency விட அதிகமா frequency வேணும், then only photoelectric effect will happen. So I can also say in the work function h mu naught, the Planck's constant into very good, the Planck's constant into the threshold frequency. இப்போ அந்த photonக்கு 5 naught இல்லனா h mu naught energy இருக்கு. Okay, h mu naught energy இருக்கு. அப்படினா what will happen? Yes, the electron will emit. So for the electron to get emitted, or let's say to escape from the metal surface, it is completely depending upon the frequency. Now on the we said energy is equal to h mu. Also we said energy is equal to hc by lambda. Hc the constant, right? Appadina it is directly proportional to 1 by lambda. 1 by lambda na there should be a value for the wavelength as well. Okay, so ipo the wavelength if it is more than this, then definitely photoelectric won't happen. Got it? So for getting an electron to escape, it is completely depending upon the energy, or let's say we can say that it is completely depending upon the frequency. Okay, Okay va? So one electron needs to escape, then it should have the minimum energy. The photon should have the minimum energy. Understood everybody? Yes or no? Yes or no? So guys, please do like the video, also share with your friends, also subscribe the channel for more videos. Okay? And also one more thing is like this photoelectric effect வந்து instantaneous process na அதோட range வந்து 10 to the power minus 9 seconds. Okay, avlo small time la இந்த process நடக்கும். Okay, in the process will happen in a very small time, in a very small time. Adanala we will call it as this is an instantaneous process. In the photoelectric effect வந்து instantaneous process. Okay, இப்போ வந்து we are going to discuss few graphs which is very important. Okay, first வந்து we are going to draw potential versus photo. Yeah, we have forgot about to mention about the potential. Okay, so let us just focus here. Okay, so right now we have the experimental setup, right? We have the experimental setup. Okay, we have a bright light is coming. You should give me an answer in the chat box. Okay, okay. So right now you should listen here. What is happening? I will cover all the chapters. Trust me, in between the session multiple times I don't want to tell you this. Adnalatha I'm telling you. Please subscribe the channel. You will be getting the updates. Okay, we will cover all the chapters. Don't worry. Okay, currently we are running the high weightage chapters. Sunday, Monday we will be going for the marathon sessions. Okay, wow. Okay. Threshold and work. Threshold na minimum frequency amount. Okay. So, இப்போ வந்து ஒரு electron, I'm talking about an electron. Threshold வந்து it is connected with the photon. Work function வந்து it is connected with the electron. Electron it needs a minimum amount of energy to escape from the surface. Okay. And the minimum energy the work function. புரிஞ்சுதா? Okay, and the minimum energy the work function. இப்போ வந்து I'm going to talk about the photon. So in the photon the photon will come and interact with the electron. Correct? So when it is interacting with the electron, it should have an energy equal to the work function. In the photon the same energy it should have. Okay, so and the energy the h mu naught. Okay, work function should be equal to the minimum energy. And the photon it will be having a minimum energy that the electron minimum energy to escape. Okay, and that will be provided by the photon. Correct? It will be the photon will be giving that energy. So and the photon if it is less than this work function, photoelectric effect won't happen. Okay, இப்போ I'm telling you this photon should have a minimum energy which is equal to work function. Okay, so we know the energy of a photon na is equal to h mu da. Okay, so h constant. So now I'm saying the work function which is equal to h mu naught. Okay, mu naught na the minimum energy required for the photon to emit, or let's say to give some energy to the electron and to escape. Understood? Okay, now we are going for again the potential, how the potential is affected. So again, let us say in the electron 3 units energy வேணும். இந்த எலக்ட்ரானுக்கு 3 units energy. இந்த 3 units கிடைச்சா மட்டும்தான் இந்த electron cathode plate ல இருந்து, or let's say the emitter plate ல இருந்து collector plate ல வரை it will move. Okay, அப்படினா I have a photon which is having 2 units of energy. Will the electron emit from the plate? Yes or no? இதுக்கு 3 units வேணும். ஆனா photonக்கு 2 units தான் இருக்கு. அப்படினா the photoelectric will happen or what? Photoelectric effect will happen or what? Yes or no? Yes or no? I think the camera is okay. Yes or no? Fine. Okay, so இப்போ it is required 3 and this is just 2, then definitely the emission won't happen. Okay, it won't happen. ஏனா இதோட minimum energy தான் 3 units. ஆனா வந்து இதுக்கு 2 units மட்டும் தான் இருக்கு. It won't happen. Next வந்து I'm going to tell you, let us say if I am having an electron, okay, அதுக்கு I mean தேவையான எனர்ஜி வந்து 3 units தான். இப்போ வந்து I'm having a photon with 5 units. Okay, so now the photoelectric effect will happen, and in the photoelectric effect I mean when it is happening, we can also say in the 3 units வந்து to escape from the metal. Again 2 units energy we have I mean the rest of the 2 units energy is there, and the 2 units energy what is the purpose of that 2 units energy? It will travel, it has to travel from the emitter plate to the collector plate. Am I right or wrong? Yes or no? Yes or no? Yes or no? It has to travel from the collector plate, so emitter plate to the collector plate. Appadina we can say when a photon having an energy h mu, okay, the energy of the photon வந்து h mu, இது வந்து 2 purpose இருக்கு. Okay, இதுக்கு வந்து 2 purpose இருக்கு. What are the purpose? What is the purpose of this h mu? The energy of the photon, first of all, it should give energy for emission of electron. Next one, it should travel from the emitter plate to the collector plate. Guys, don't forget to like, subscribe the channel, also share with your friends. Okay, so இப்போ வந்து இந்த photonக்கு h mu energy இருக்கு. And the h mu energy is used for 2 purpose. First one வந்து to give the work function, to give the minimum energy required for the electron to escape. அதுக்கப்புறம் the electron should travel from the emitter to the collector, so it is used for 2 purpose. So அப்படினா இந்த emit பண்றதுக்கு தேவையான எனர்ஜி என்ன? அதுதான் work function plus traveling half mv square. So I can just say that h mu naught plus half mv square. இதுதான் ஐன்ஸ்டீனோட relation. Okay, the total energy of the photon is used for the work function as well as to travel from the emitter plate to the collector plate. Understood everybody? Yes or no? Yes or no? Okay, voice again. Any issue? Very good. Okay, so இப்போ வந்து we have we have the experimental setup again. Okay, right now I am reversing the potential. We have the commutator, right? So we can reverse the potential. So இப்போ வந்து what will happen when the electron coming from here, there will be a opposition, right? So in the electron வந்து அதோட minimum energy கிடைச்சிருக்கு, so it was very excited, it is coming to the emitter collector plate. அப்போ வந்து இந்த reverse பண்ணதுனால when we have reversed the potential, what happened? Yes, this will start resist. So at some point the electron வந்து it cannot move, which means electron ஓட flow stop ஆயிடுச்சு. அப்படினா current இல்ல. அந்த current stop பண்றதுக்காக we are giving some potential. Okay, so in the potential when we are increasing the potential, at some point in the current வந்து or let's say in the electronக்கு வந்து move ஆகுது, it cannot even move, which means flow of electrons இல்லனா what is the meaning? No current. அந்த potential தான் stopping potential. The stopping potential is nothing but the potential at which the current becomes, the photo current becomes 0. Understood? Got it? So இப்போ வந்து I can say that the potential energy will be coming as EVS. VS is the stopping potential. So tell me guys, what is stopping potential? Stopping potential na very simple. So usually வந்து electron emitter plate la irundha, it will be, once it got the energy, it will emit and it will travel to the collector plate. ஆனா வந்து இப்போ we have changed the direction. Okay, இப்போ வந்து இங்க ரொம்ப negativity. Okay, here there is a lots of negativity. அப்படினா what will happen? This electron will try to come here, ஆனா வந்து it will oppose. So here in the kinetic energy, idoda kinetic energy, it is using its maximum energy. Ana vanda in the potential energy idoda stop pannirukku. Appadina I can say the maximum kinetic energy is nothing but the potential energy. Potential energy is nothing but the charge into the stopping potential. Inge electron da charge, so charge into stopping potential. Appadina I can again write, we have mentioned this h mu, the energy is used for work function plus this traveling kinetic energy. Appadina kinetic energy I am replacing with the maximum kinetic energy I am replacing with the potential energy. Now I got the another equation. So these equations are very important because we can expect the numericals from it. Purinjada everybody? Everybody, are you guys here? Say yes or no. I have started at 6 only. Guys, okay? Are you there? Yes or no? Tell me. I can't see you anybody here. Yes, very good, Shankaran. Yes, 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 yes. Very good, very good, very good. Super. Okay, so இப்போ வந்து இந்த equation வந்து ரொம்ப important. So you should understand this much. Okay, you should understand this much. Let us just summarize whatever we have studied. Okay, இப்போ வந்து we have an electron or let's say we have a plate. அதுல வந்து free electrons இருக்கு. Okay, அதுல வந்து free electrons இருக்கு. இப்போ வந்து what we need to do, yes, in the light வந்து using the light energy we need to excite the electrons. அப்படினா இந்த லைட்டுக்கு வந்து ஒரே ஒரு கிரைட்டீரியா தான். இந்த லைட்ல வந்து பார்ட்டிகல் நேச்சர் இருக்கு. ஓகே, இந்த எலக்ட்ரானோட இந்த லைட்டுக்கு இன்டராக்ட் பண்ணனும்னா இந்த லைட்டுக்கு பார்ட்டிகல் நேச்சர் வேணும். அந்த பார்ட்டிகல் நேச்சர் தான் ஃபோட்டான். ஓகே, சோ இப்போ வந்து இந்த ஃபோட்டான் வந்து இட் இஸ் கோயிங் டு இன்டராக்ட் வித் தி எலக்ட்ரான். one ஃபோட்டானுக்கு one எலக்ட்ரான் தான். அப்படினா இந்த ஃபோட்டான் வந்து இன்டராக்ட் பண்ணும்போது this photon should have a minimum energy and that minimum energy is nothing but work function. Work function na enna, in the electronic required ana minimum energy to escape from the metal surface. Okay, so appadina if I am giving a high frequency light, appadina this electron will definitely escape. Yeah, it is getting the minimum energy because I am giving a high energy, right? So now we understood the energy part. Ipo vanda I am giving a dim light. Okay, idoda high energy da, adukku high frequency light. Okay, just understand, we have a high frequency light ana vanda dim light. You should give me an answer whether the photoelectric effect will happen or what. Okay, high frequency, it is more than the work function. Okay, so it is more than the threshold frequency. Appadina in the case la high frequency dim light da photoelectric effect will happen or what? Tell me guys in the chat box please. Everybody let me know on the chat box. What will happen? Photoelectric will happen? Of course yes. Why? This photoelectric effect ku irukra ore oru condition enna na, it should get the minimum energy. That is done, high frequency. And dim light, bright light, ange enna problem? I mean it is not depending upon the emission. How many electrons were ejected? That is depending upon the dim light, bright light intensity. Intensity is more, number of photons more, number of electrons emitted more, photocurrent more. Okay, now we are going for the few important graphs. Okay, these are all very important. So effect of collector potential on photoelectric effect. So ipo neenga paathena the potential we are increasing. Okay, potential we are increasing. So once if it is we are connected with the battery. Okay, so now what will happen? The electrons will move to the collector plate. No worries. Again we are increasing the potential. Again this will happen. No worries, nothing, no problem at all. But once after some time what will happen? All the electrons has been reached here. Okay, all the electrons has been reached here, which means there is no more current flow because all the people have reached here. It is something like, let's say the question paper is very easy. The upcoming CBSE physics exam is going to be very easy, very easy. Okay, everyone will get pass. Okay, everyone will be getting pass mark. Am I right or wrong? Am I right or wrong? Tell me in the chat box. Yes, yes or no? If it is easy, everyone will be getting the passing mark, right? Correct. Okay, so now what happened? Now we are reversing it. Okay, now we are, so that current is known as the saturation current. Okay, saturation current. Okay, இப்போ வந்து we are reverse the direction. அப்படினா what will happen? Exam வந்து difficult ஆச்சு. Even the top student can't get the pass marks. Okay, so avlo tough on exam na what will happen? Definitely everyone will fail. Okay, that is what is happening in this. Okay, this is nothing but the stopping potential. Okay, இப்போ வந்து you can just see that we have the potential over here, and now the intensity increases. Okay, in the first case you can see that the intensity is maximum for the I3, then even less for I2, then I1. So intensity more na, it will affect the saturation current. Okay, saturation current when the intensity more na, more photons will be coming, more electrons will be emitted, more photo current. So intensity vanda, it will be depending upon the saturation current. Ana vanda, it is not going to stop, or it is not going to affect the stopping potential. In the stopping potential affect pannanona, what we should do? We should make the relation with the frequency. Okay, frequency adhigam marunda, what will happen? The stopping potential. Let us say, you just imagine. Okay, you just imagine, ipo vanda we have a high energetic photon is coming, highly energetic. So இப்போ வந்து இந்த highly energetic electron வந்து இந்த collector plate emitter plate it is coming. So the potential energy also should increase, right? If the electron which is coming, if it is having less energy, potential also less. This is to stop, right? Stopping potential, which means we need to stop the electron. If the energy of electron is less, definitely potential energy also less. So அப்படினா frequency increase ஆனா stopping potential will also increase. ஆனா அது வந்து it is not going to affect the saturation current. It is not going to affect the saturation current. So guys, if you understood, like the video, share the video, as well as subscribe the channel right now itself. So I can say that right now this frequency is not depending upon the photo current, the saturation current. ஆனா வந்து frequency increase ஆச்சுனா stopping potential கூட increase ஆகும். புரிஞ்சுதா everybody? So next வந்து we are plotting potential, stopping potential versus the frequency. Now we are going to draw. Right now, you know h mu is equal to, what is the relation? H mu naught plus EVS, the stopping potential. Correct? So here we have mentioned V naught. Let it be. Okay. Now in the y axis la vantu what we need? We need the stopping potential, and x axis la vantu we need the frequency. Appadina I'm just going to compare this with the straight line equation. Y is equal to mx plus c. Y na enna? Potential. So appadina I just wanted to rearrange this equation. I want potential this side. So EV naught will be equal to h mu minus h mu naught. Now I want V naught only. So adakaga I will be dividing this with E. Okay. So ipo vanda I got an equation which is exactly matches with the y is equal to mx plus c. Y na V naught, correct, stopping potential. Next one the m na enna? H by E. Okay, m vanda h by E plus c. Okay, the y intercept. Okay, y intercept vanda it will be coming as h mu naught by E. Everybody understood? Yes or no? Yes or no? Which one you couldn't understand? Can you just let me know in the chat box? Okay, so ipo vanda we have a relation h mu which is equal to h mu naught plus the stopping potential. Appadina we need potential only in this side, so we will make rearrangement, and then we will be comparing this equation with this equation. Appadina the slope vanda h by E. Okay, slope vanda h by E. slope வந்து h by e na, so in this case we can see that both the cases, metal A and metal B, h by e na a constant value, so adanala slope வந்து for all the metal it is going to be same. Okay, idu வந்து it is going to be same. Understood? Got the idea? Yes or no? Everybody please let me know in the chat box. Please let me know on the chat box, please. Okay, so now we have a question over here. I'll just explain how to do it. You can just do it and you should give me the answer in the chat box. That is a homework for you. Okay, the work function of cesium is 2.14. Okay, phi naught 2.14 electron volt. Threshold frequency of cesium. Appadina we know phi naught which is equal to h mu naught. Appadina phi naught by h which is equal to mu naught. So phi naught 2.14 electron volt divided by h naught 6 into 6.6 into 10 to the power minus 34 joule second. Now we should find the wavelength of the incident light if the photocurrent is brought to zero by a stopping potential. Now we have stopping potential which is equal to 0.60 volt. Appadina we should find the wavelength of the incident. So now we know hc by lambda. Yena h mu na hc by lambda which is equal to h mu naught, that is work function which is already given in the question, and plus e 1.6 into 10 to the power minus 19 into the value potential, that is going to be 60. hc you can substitute and you can find the answer, and you should tell me what is going to be lambda. So you have to give me the answer in the chat box. This is nothing but our homework. Okay, so this is what we should understand in the experimental setup. Now we should understand one more thing. We got to know one important fact, that this is having a wave nature as well as the particle nature. So why this wave theory cannot satisfy this? Yeah, now first reason in the process instantaneous, but according to wave theory this is a long time consuming process. Okay, adutha the major reason why wave theory, okay, why wave theory is failure of wave theory, that we are going to explain. Okay, first according to this one, the particle nature in the process, photoelectric effect as I mentioned 10 to the power minus 9 seconds la nadakra vishayam da. Appadina அது instantaneous. ஆனா wave theory, according to wave theory இது time consume ஆகிற process தான். Okay, and next according to wave theory intensity அதிகமா இருந்தா it should get more energy. ஆனா we know energy is not depending upon it. Correct? Yes or no? Yes or no? Yes or no? Exactly the same way we can say the stopping potential, that is also not depending upon the intensity. According to wave theory it is supposed to be depend upon. Got it? Yes or no? So ipo we are going, we have discussed about the particle nature. Also we know the wave nature. So ipo we know in the light it is having particle nature, adanala da adukku momentum irukku. Okay, energy kuda irukku. Energy na h mu, correct ah? Energy na h mu. Yes or no? Yes or no? Please let me know in the chat box, please. Yes or no? What is the energy? What is the energy? What is the energy? It is nothing but h mu, right? Also we can say hc by lambda. Correct ah? Correct ah, wrong ah? Yes or no? இப்போ we have the momentum and the value h by lambda. Okay, so in the wave or let's say in the light particle nature இருக்கிறதுனால அதுக்கு momentum இருக்கு, energy இருக்கு. Okay, and the momentum h by lambda and energy hc by lambda. Okay, so even we can also say this is nothing but E by C. Energy by C is nothing but momentum. Okay. Now in the wave nature we can say that it should have a wavelength. It should have a wavelength, and we will call it as, okay, we will call it as matter waves. Okay, matter waves, and we can see this matter waves in the small things like electron, proton and all. Okay, and adoda lambda, the wavelength one, what is going to be the wavelength? Can you just give me the answer in the chat box, please, everybody? What is going to be the wavelength of the matter wave? What is going to be that? Matter wave oda particle wave behavior irukku, adu represent பண்றதுக்காக we were calling it as matter waves. Also we can call de Broglie wave. Okay, so இப்போ வந்து we can say this is nothing but h by mv. ஆனா இது வந்து we can see in small particles like electron, proton. Okay, so அதுதான் ரொம்ப முக்கியமான விஷயம். So இப்போ வந்து you can see that இந்த சைடுல particle nature momentum E, ஆனா அது define பண்றது வந்து we are using the wave property. இங்க வந்து இது வந்து wave property தான். Okay, wave property தான். So right sideல பார்க்கும்போது we can see mass and velocity வந்து அது particle behavior தான். Okay, so அப்ப waveக்கு வந்து particle behavior இருக்கு, particleக்கு வந்து wave behavior கூட இருக்கு. Okay, also we can also rewrite this lambda in terms of energy. Okay, lambda வந்து momentum we can just write as mv. So we can rewrite, how we can just rewrite this momentum? How we can rewrite this momentum? Sorry, lambda. How we can rewrite? இது வந்து h by p. p na enna? p square by 2m the energy. அப்படினா you can just write root 2 m k. Okay, k வந்து kinetic energy, because we have studied this relation, right? Yes or no? Yes or no? இப்போ வந்து we can just rewrite k வந்து root of 2m charge into potential. So we will be getting இப்போ வந்து for an electron h 2mq வந்து constant தான். அப்படினா we can say lambda வந்து proportional to 1 by root v. Everybody understood the things we have explained today? Can I let me know? Yes, wavelength வந்து h by mv. mv na momentum. Done? Okay, very good. So இப்போ வந்து we have done with the dual nature as well. As I mentioned, this is not enough. We need to practice more questions. அது வந்து we will be starting from Tuesday onwards. For each chapter, at least we should do 100 questions. So you guys have to be there in the next week. Complete we will be packed with physics. Sunday irundhu we will be starting our fight with physics. Okay, so everybody should be there, and if you like the session, you should give me a comment. Now your feedback is mandatory, so you should give me a feedback in the comment box. Also guys, share with your friends, study well, and there are many videos for you guys. It is there in the channel, so check out. Thank you so much, and bye, take care everybody. Yes, it is EV or QV. Q na enna? Charge. Electron oda charge we can replace with E. That's it, nothing else. Okay, fine. 4 days we will be having classes. Sunday onwards special class, the avlo the difference, nothing else. Okay, so bye Jenny, Lalit, Radhika. Thank you so much Radhika, thank you so much. Hi Sankaran. Yes, evening star. Hi. Yes Lalit. You should give me the answer in the comment box. I don't want anything in the chat box. I won't read. Okay, so see you guys. Bye, good night, take care, drink a plenty of water. Always be healthy. We need energy to crack physics exam. Even with one day if you are sick, we will feel very low, so we don't want it. So everyone should study. Okay, for that we should be healthy. So see you. Bye, see you again. Bye.